Hey everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. Today, this is one of such events. If you want to find out more about the events we have, there is a link in the description. So click on that link, check it out. Right now, we actually have quite a few events in our pipeline, but we need to put them on the website. But keep an eye on it anyways. So we will put them, you'll see them. And then don't forget to subscribe to our YouTube channel. So this is the most reliable way of getting notified when our stream starts. And last but not least, do not forget to join our data community, where you can hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your questions, and we will be covering your questions during the interview. So that's the usual introduction I do. Also, I'm a bit sleepy, but I hope it all goes well. So I guess if you're ready, I have the questions prepared in front of me.
Yeah.
If you're ready, we can start.
Yeah, sounds good. Ready.
Today on the podcast, we're joined by Aishwarya. Do I pronounce your name correctly?
Yes, that is right.
Yeah, good. A machine learning engineer at Waymo, formerly part of Tesla's Autopilot AI team and a Cambridge Mellon University alumni. Aishwarya has worked across some of the toughest applied AI problems, financial recommendation systems at Morgan Stanley, multimodal research at CMU, perception and video understanding at Tesla, and now gesture and pedestrian semantics at Waymo. She has also contributed to AI for social good, including a malaria mapping project in Africa that achieved real-world impact at scale. Welcome to this event.
Hi, thank you for having me.
Yeah, that's quite a nice bio. Especially, I don't know, probably what you do now at the Waymo and Tesla is challenging, but for me also, Morgan Stanley sounds very challenging because I worked a little near high frequency trading, so I wasn't actually working on the system that we were doing high frequency trading, but we were doing some how to say analytics on top of this data. It was huge, so
Yeah.
probably quite challenging. So can you tell us? I just outlined your career journey, but can you tell us more about this?
Yeah, so I think, like you mentioned, at Morgan Stanley, it was a lot of data. So I was a big data engineer at Morgan Stanley, and I basically did that, handle all this huge amounts of data. And I was there when Morgan Stanley, they were doing this acquisition of E-Trade. So we had like a lot more data coming in. So my role there was, handling all this data. How do we connect the different dots? How do we analyze them together? And from there I like realized that there's so much of data that it has so much of value that we don't need to do all the things that we do manually. And that was back, I guess, in 2018, and the whole AI domain, the AI bubble hadn't like formed yet, but it was getting there. People were realizing how important it was, and finance was one of the last fields to take on the machine learning aspect, the AI aspect. So we were onboarding systems, and that's when I decided to like get a hand at it and like try some of like begin with some of the smaller systems, like recommendation engines and stuff that was already well known in the AI domain. So I started off as that, and then we decided to get a bit more I guess researchy with that. We tried out like graph neural networks, which was some of the more complicated topics at that point. And that's when I realized that, oh, it's there's so much to be learned here, and there's so many, this field is so vast. So that's when I decided to like pursue a master's.
Mhm.
And I like decided to join Carnegie Mellon University, and my program, it was like sorry, it was a mix of data science and machine learning. So I had like I could draw upon both my experiences and what I wanted to learn and where I wanted to get at. And during CMU, I was more like inclined towards projects that involved a lot of computer vision. So I was involved in this product for like navigational app for blind people. So it's called like AI Guide Dog. So it like takes in the world and navigates people without vision. And from there, I got into Tesla because it's also similar, like computer vision domain and navigation related stuff. And that's where my self-driving journey began. And then from Tesla to Waymo, it's like a similar domain, but different kinds of products. Like some different like differences are there.
Mhm.
And yeah, that's where I am at Waymo right now,
Mhm.
in the self-driving domain. Started from finance, reached in
Yeah,
a different domain, but yeah.
that's an interesting journey. This app that you developed for blind people, can you tell us more about it? Like, how does it work? Is it like they hold their phone and then it tells where to go or describes things?
Yeah, sorry. So yeah, for this app, like the goal was that uh, people without vision, they should be able to navigate the world just as sighted people do. So this app is basically their eyes. So you just like hang it around your neck and you walk with it, and it gets a world view of what is in front of you, and then via like live audio instructions, it tells you like keep walking straight, and if you've entered a destination based on that, take left or right, or stop at a traffic signal, or there's like pedestrian crossings. So it gives you instructions via audio.
Interesting. And is it something you did just as a pet project? Was it a part of a company? Was it AI for social good project? How did you get involved?
Yeah. So my program has this thing called the capstone project. So every year,
Uh,
like you either pair up with a professor or someone from the industry who already has a very interesting project, and then you work on it. So this project was from an alumni of CMU, and he currently works at Pinterest. But he started this whole project, and this was like the third iteration where he worked with two groups of folks before, and then my team onboarded on it.
Okay. But was it like a community AI for social good project or was it a company?
I would say it was like more of a volunteer project.
Uh-huh.
So
Yeah.
it's just like every year a group of volunteers from CMU work on it, and then we make some progress, and then we
Mm.
pass it on to the next group.
That's a
So
very interesting concept.
yeah, so before me, like two batches of people had worked on it. So they were like mentors to us.
Uh-huh.
And then when I got done, mentored another batch that came after me. So this is like in its fifth iteration now. Like there have been two batches after me, and they are making more and more progress on this front.
That's really that's a really nice idea because well, we have courses at Datadogs Club. And for me, I immediately started thinking, how can I implement something like this? Because it sounds so amazing. And with the community we have, I see that people from the previous iterations, they have people who are currently doing courses. So
Mhm.
having a project like that for them to actually sharpen the skills they picked up during the courses, that's a really good idea.
Yeah, and it doesn't need to be like, done, like it's a big thing, right? There's so many moving components. It can't be built in 1 year by a given cohort, or even in 6 months by a given cohort. So you like pick up small pieces. Like the first one started with like the data efforts. The second one started building like baseline models. The third one like tried improving it with evals and stuff. So you
Mm.
do it iteratively. So it's a good idea, yeah.
Yeah. Do you know if this app is accessible in App Store?
Not yet. So the next community, like the new batch of students, are going to be working on the app. We have the model, but it's still in beta phase.
Mhm.
We are doing a lot of testing because it's kind of like a sensitive use case, and yeah,
Yeah, yeah, I can
yeah.
imagine. I recently participated in a marathon. People who know me, they would roll their eyes because I wouldn't shut up. Of course, I've been preparing for so long. uh, but yeah, so the reason I thought about this, blind people also, or people with, how to say, with vision problems, and also blind, completely blind, who don't see at all, they took part in this. but they were running with a guide. So there was a person who was running with them, and they were holding their hands and running
Yeah.
together. And I thought, like, it's so amazing to include them too, like, because they also want to be a part of this event, but because they cannot see, it's very difficult. But what they did, they allowed they call them guides to also join and be the leads. And this is so amazing. And I guess, well, maybe with this app, they wouldn't be able to run an event, a race. But yeah, this is one step closer to this, right?
Yeah, that's the hope. Like, they don't need like a person or some rely on someone. They can just have their app and that can be their guide for the world. Yeah.
Mhm. And also with these VR glasses, you probably heard, like I think Meta has them, some other
Hmm.
companies have them. So you put them in your eyes and they have cameras, right? And the cameras, they have a broader, um, how to say, vision than mobile phones,
Yeah, yes.
right? So
They
maybe
have
this
a
is
wider
something that,
world view.
yeah, maybe this is something that future alumni can work on, right? Or
Fair
like
idea.
LiDAR. Because I
Yeah,
guess you use
I think
LiDAR in cars, right? Not necessarily cameras.
yeah, that's like, th those are the things that we're trying to work around because it needs to be cost efficient and, we can't afford to put like LiDARs and stuff. So a mobile phone, everyone has it like today's
Yeah,
world.
yeah.
So we're trying to fit it on what everyone has.
How expensive is LiDAR?
I think it depends on the quality. Like, you can get from somewhere like really cheap to extremely high end. So yeah, I
How
guess
how
the
do you
ones
actually
used in
pronounce it? LiDAR, LiDAR,
it's LiDAR. Yeah.
LiDAR. So this is, I know radar. So radar emits radio frequencies and one waits back to the frequency to come back to the wave to come back, right? And based on that, the radar can estimate if there's something
Hmm.
and if it's moving and so on. Whales do this, right? So they make sound,
Yeah.
or I don't know, maybe not whales, but some other
I think it's
um,
bats.
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 Yeah, yeah.
Yeah.
And the same thing. LiDAR has kind of similar idea, but it's instead of a radio wave, it uses lasers, right?
It's light. Yes, that's right. Like
Light.
light rays. Yes.
Okay.
That's why
Okay.
the LiDAR thing. Yeah.
Okay. I thought it's laser there. Okay.
Similar. Like I think it's one
Similar.
of the light frequencies.
Okay. Okay. And
Yeah.
I don't know if you can disclose or talk about things you do at work, but I know that these things they are used often for cars, right? For self-driving.
Yeah, I think it like depends on the stack. Some companies they do use like most of the like fully self-driving where there is like absolutely no driver use it. Whereas if you see some of the Tesla systems, they do not use it at all. They rely solely on the cameras. Yeah.
Mm-hmm. So Tesla, I took a few times a taxi, which turned out to be Tesla, and for me it was so fun to watch. They have this screen, and as the car drives, they start showing like cars and people and stuff like around the
Yeah.
car, right? And for me, it was always curious to see like when it makes mistakes or when it doesn't make mistake. Well, but for me, it was kind of fun to watch. So the ride was more entertaining than a usual, I don't know, um, Toyota ride, right? Because I could look at the screen.
Yeah.
So this thing works with the camera, right? Bless you.
Sorry, I think I came down with a flu in the evening.
I'm
So
sorry.
yeah, like I have cold. It might take like
I hope
brief.
you recover very quickly.
Yeah. Sorry. Like, could you please quickly repeat the question for me?
Yeah, yeah. So I was talking about these Tesla cars, right? And in Tesla, there's a screen
Mhm.
that shows that detects people, cars, bikes or whatnot.
Yeah.
Mm. Do you know how this thing works? Like, does it use just video cameras, or
Yes.
there is
So
something
I think
smarter?
that's like the USP of Tesla systems that, they, because LiDAR is expensive, or at least the good quality ones, and they want to be like really scalable. They rely on just cameras, but it's not just one camera. There's like, cameras all around the car. So you get a view from all around, like a 360 view of the system. And you kind of like run your models on top of it that can make use of these different views of the world and see basically all around the car. So basically, the car has a much better holistic view of the world than a person, like a
Mhm.
person driving the car. Yeah.
Yeah, because we cannot have cameras on our back, right? On our sides.
Yep. That's yeah.
Hmm.
So yeah, I think that's the goal with self-driving, is to make like driving safer once it accomplishes that level of, the AI reaches that level. Yeah.
Hmm. But what is the screen for? Like, this screen is for self-driving, right? But in these cases, when I took a taxi, it was Uber or some other ride-hailing service, and they were actually driving. The drivers were driving, not the car. So what's the point of this
Yeah,
thing?
I think it's more about like at this point, so there's two purposes, like, in like long drives, or if the stop traffic is like stop and go, you can just put it in the autopilot mode and you don't need to like be constantly on the wheel and constantly like super alert. And then that car takes you. Like I remember 2 years ago, I took a trip to like Vegas. It was like a 13-hour drive one way and then 13 hours back, and I was the only person driving, and like the car aided me all the way. Like it drove 95% of the time, and I was like just there. And it
Hmm.
was so much better because, I couldn't have made it without that. Like 12 hours is too much. So
Hmm.
it's like an assistance system. And sometimes like people just drive because they don't trust it. So it's
Hmm.
like, okay, better me driving than the car doing
Hmm.
something wrong. So it's also
I
about the
wonder if
trust factor.
there is any statistics about that.
There is statistics about like
I
failure
mean,
rates.
people are saying that it's better me driving than AI, right? Or whatever self-driving thing. But like the question is, who actually drives better?
I
Because
think
people might be overconfident in their driving skills, right? But for some simple
that's
cases, like you
true.
said, when you need to go to Vegas, I don't know what kind of road is there, but maybe it's like most of the time it's just straight, right?
Yeah, I think like it's a highway, so it's not like, there's a lot of traffic lights and stuff. You just go straight and you go along the route, and it's like there's a patch which is like just 150 miles straight, and like a normal person would just be so bored out of their mind
Hmm.
if they
Yeah.
had to drive that much.
So in Berlin, it's probably difficult because there are bikes.
Yeah.
The streets are quite narrow, um, like crazy bicycle riders who can jump on you out of nowhere and like other things. I guess that's why they don't use
Yeah,
self-driving.
I think Tesla is trying to get into the European markets though with its
Mhm.
autopilot. Like at least when I was trying to like when I was there, I was working on some European road signs, like speed limit signs. So yeah.
Yeah, but also it's regulated, right? You're right. So maybe they cannot use
Mhm.
a self-driving yet.
Not yet, yes, yeah.
I
Yeah,
see, I see. Makes sense. Because
yeah.
I'm originally from Russia, and I know in Russia, in Moscow, some cars already drive without drivers. I guess in San Francisco too, right?
Yes, yeah.
Um,
SF also has Waymo, which has like no driver at all. So I guess very
so
people
you get
people here are
and
more trusting.
hmm, so you get something like Uber, and then a car comes and there is no driver, right?
Yes, there's no one there.
Okay, that's
If you visit SF next time, like be sure to take a Waymo. It's
okay,
quite the tourist attraction right now over here.
okay, okay. That's where you work, right?
Yeah, yeah.
Okay, that's why. Is there an app called Waymo, right?
Yes, there's an app called Waymo through which you can hail it, and I think in some cities they've also partnered with Uber and Lyft so that you can call via Uber as well.
Yeah, how much about your current position can you talk? Because you mentioned that, or we at least know that you work on gesture recognition, right? So can you tell us more about that and how much? I don't know, but I would be pretty curious to know.
Yeah, I think I can like give a high level picture. It's
Mhm,
basically about trying to understand, if there's like a police officer or a construction worker trying to guide traffic, like, if there's like a big event or
mhm. So if there is a
there's
police officer, slow down, right?
yeah, no, like they tell you to stop or they tell you to go
I know.
or they tell you to like yeah. So yeah, that's the humans like slow down when there's a police officer.
Yeah.
That's the human brain. The car
Uh-huh.
tries to stay in the traffic rules.
Mhm,
But yeah, I basically try to understand what they want to say and communicate with the car and like try to modify its route or modify its behavior according to
mhm.
what they're communicating. So
Because I
yeah,
guess in your case, in case of Waymo, if you say that there is a ride-hailing service, the car comes without the driver, and then all of a sudden there is an event like I don't know, Pride Day or whatever, with a lot of people,
Mhm.
like what the car should do, right? So, because in training data, I guess it's less common to have things like that, or like a traffic light breaks and there
Yes,
is a police
yeah.
officer controlling the traffic.
Yeah, I think all of these cases are covered. Like Waymo has been in business since like I think 15 years. I would say like they've been working on the product and try to cover mo many of the cases that we have. So, the broken traffic light, large crowds of people, it's pretty good around. There are sometimes events and game nights, and it actually does really well over there. So, and also like, during these cases, there are these police officers controlling the traffic and like directing traffic. And my job is to make the Waymo better at understanding.
Hmm. How much can you talk about this project? Because I wonder how does it actually work? Like what kind of tech do you use? It must
Um,
be something super fast, right?
yeah.
So I know you cannot go into details, but I guess it should be something super fast because like you need to make this decision in real life, in real time, right? So something like I don't know, yellow or something.
Yeah, there are like a bunch of in-house models that use like, cameras, LiDAR data, and like all the sensor information that we have or we get from the car. And it's like Waymo does not publish its models, what it uses. So these are internal model that, they are optimized to run on the car and they're optimized to run really fast. So it's probably not the same neural network that was trained. It was like, we use various techniques to make it much faster and run much faster on the car to like detect in very quick amounts of time and detect like multiple times a second about what's happening with the world. Yeah.
How is this process called when you take a big model and make it smaller and faster?
I guess there's a bunch of ways to do it. Like, publicly available ways are like something like, you quantize the
Yeah,
model,
yeah, exactly.
you,
This is the word I
yes,
was looking for, quantization.
quantization, yes. So you make it like you make it smaller, you make it faster with quantization. So many of similar techniques, but there are a whole bunch of other stuff that we also do internally.
Mhm.
Yeah, I guess like I think that's the extent of it.
Yeah, yeah, that's fine.
Yeah,
That's fine.
then
I was just
that's about
thinking not to torture you and put you in an uncomfortable position by asking more, and I was thinking, what should I ask next? Because you also did a few other interesting things, and one of them, which I find quite interesting, is this malaria mapping project in Africa. Um, can you tell us more about this project?
Yeah, I think this was when I was in Morgan Stanley and I was like, oh, this domain is really interesting and I want to do more projects about this. So I joined this organization called Omdina, and basically they have like AI for good projects where you have a nonprofit company that comes in with their problem and you have these volunteer ML engineers. Some of them are trying to learn, some of them are experts and they want to contribute to the community. And they put you in like groups of 30, 40 people who work together on this problem. So there was this non-profit organization called Zap Malaria. They were trying to lead efforts for fumigation in Africa. So, the first iteration was to just like go in places and fumigate places where there could be high possibility of malaria mosquitoes, so that to prevent the breeding of mosquitoes and the spread of malaria in those regions. What they wanted us to do was to like determine, make this process more efficient. They don't want to go to every region or every city in a given region and fumigate. They only want to target places where there's a high probability of mosquitoes. So they wanted to use machine learning models or AI to do that. So what we thought that, okay, if we have like satellite images or we have some knowledge of where could be marshy lands or where areas where water stagnates, which is typically where mosquitoes have breeding grounds, we could just like identify these areas, and these people could just go with their fumigation and just fumigate those areas, and that would be much more efficient. It would save like so many manpower, so much cost. And for these kind of nonprofits, cost is a very big, I guess, consideration. So I guess with this team, we worked in multiple groups. One team tried to use satellite images to detect like water bodies, stagnant water bodies. What my model did was it used topographic information. So we have this Google data gives you information about the geography of a particular region. And then you try to basically train a model to identify what could be like low-lying areas where there's a high possibility of water stagnating, and detect those areas and let them know. So I think at the end, like we used kind of an ensemble system that could use satellite images, topographic information, and give you this data, which they later made some changes and integrated into their whole model. And I think their website also has some good, very good results that they achieved with our models with this. But yeah, it was like a completely volunteer-based AI for good project.
So you worked at Morgan Stanley and managed to also contribute to AI for Social Good project. Because I don't
Yes.
know about Morgan Stanley, but usually these financial institutions are not known for good work-life balance.
Yeah, I think like it's I was there for 2 years, so I was already pretty efficient with all the systems and I knew where everything was. So I was and I was interested in learning more, because in financial institutions generally, these newer technologies like ML and all, it's not easily adoptable. So it's really
Yeah.
hard to get started a project. So I worked basically on weekends for this project that I had.
Yeah,
Yeah.
makes sense. Yeah, like I have PTSD now, like when you talk about, because I worked at a bank too. It was 2012, so it was a while ago. And it was so difficult to get even like a new database like Mongo to use.
Hmm.
Like let alone starting a new project that involves machine learning. No, forget about that. Uh,
Yeah.
and we deploy it even once per month. And if we didn't have a chance to prepare some things for the deployment, because there is a process, like you need to do some sort of audit. I don't know. I don't remember.
Yes.
And if you
I
miss this
remember.
deadline, then you wait for 1 month for the next cycle, right? And then only then you can see your work actually being applied to real data. And that was frustrating, right? Well, I guess there are reasons why there are these bureaucratic processes, right? Because like it's money.
Yeah, I think I 100% like agree, and I can resonate with what you're saying. There are these like big processes that happen before every release and deployment that you must do every single time, and it after a point it gets repetitive, and it's like even for like putting the smallest thing in production, you need to go through this, and at some point it gets to you, and you're like,
Mm-hmm.
I want to like do innovation, I want to like make impact. I don't want to do like get caught in processes and stuff.
Hmm.
So yeah.
Which makes me wonder now, how does it work with self-driving cars? Because it's also not a thing you can easily roll out, right? So first of all, there is this component that like you cannot really afford having bugs there, right? Because like if there is a bug and then a car misbehaves and I don't know hits a traffic light, and then like it's good if nobody gets injured, but like what if somebody gets injured? Then it's super bad, right? Especially with competitiveness, like there are so many, well, there are multiple um, cars who like how to say companies that work on self-driving. Of course you want to be the best one, right? So I guess you have to be super careful when you work on things like that. So how do you go about deployment in this case?
Yeah, I think like there is again a lot, I would say multi-month process of, deploying any, I guess, news release or software because, like you mentioned, it's a very sensitive and safety critical domain. So we want to be absolutely sure that it doesn't like negatively impact and doesn't have any bad behavior out in the open or out in the wild in the world.
Mm,
So, yes, I think there are different components. Every time you push a change, you do these whole bunch of evals. You try to rerun from existing logs. You rerun a lot of different evaluations, and then you combine your changes with all other changes. And then again, like for many months, you have drivers driving in multiple areas, testing out the software, and like
mm,
after you have accumulated enough data points that okay, this is safe and this is good to go, only then you deploy it. But yeah, the joint evals and the drivers actually driving around, like we engineers are not involved so much with that. So
mm,
that process has like it has a very different team and that is very well managed, and they go
mhm.
through it.
Okay.
But even
So
as
there are
engineers,
process.
yeah, there is tons of. I would say there's a lot more than financial company because,
Mm,
in like in Morgan Stanley, I've seen there's been losses, there's been millions of dollars of losses, but that you can recover. But this is like someone's life or
yeah,
someone's
yeah.
safety, and it's much more important.
Hmm. Yeah, that's interesting. Um, which reminds me of this case. Remember a few years back, there was a bug in Windows computers and all the airports had blue screen of death. Uh, what was that?
Yeah,
CrowdStrike, right? That was CrowdStrike.
yeah, CrowdStrike. I think
Yeah.
yes, CrowdStrike.
Nobody knew about this thing, that this thing existed until like I had no idea this company ever existed. But
Yeah, I
turns out
think
to
they
be
got
such a
like a
major provider.
lot of they got a lot of publicity out of that negative
Yeah.
one, but now we know what it is.
Yeah, and so the story there was that they rolled something out and then it broke, right?
Yes, yeah. I think the testing they missed some test cases and something very unexpected happened over there.
Mm,
I don't know
yeah.
fully what happened though, but it
Hmm.
was a talk of the town, I would say.
Hmm. Yeah, but I guess what you work with is kind of similar in a sense that there is also the hardware component, right? So in Morgan Stanley, I don't know about you, but I assumed it was probably just software, right? You didn't need to,
Yes, yeah.
of course, like you run on a computer, but chances are that you don't run native C code. Most likely it's Java or Python or I don't know, something like that.
Yeah, yes.
Um, but like once you need to use something low level, something native, and you need to be closer to hardware, then things can get complicated, right? And in case of self-driving, you're very, very closely connected with hardware because you actually need to, I don't know, steer the wheel or uh, hit the brakes or whatever.
Yeah, I guess definitely connected to hardware, but for my role specifically, I mostly work on the software that drives it. And
Yeah,
then there are different teams that work on the hardware aspect, like, or connection between the hardware and
mm,
software where you do this whole, like, making the
makes
model
sense. Makes
faster and
sense.
stuff. But
Mhm.
yes, it like every time you push any new change, there's this whole suite that needs to run, and it's a
Mhm.
very comprehensive, very thorough evals. Yes.
Are you working on any side projects right now?
Not right now. What I'm doing right now is the AI guide dog thing that I was doing. I'm still mentoring a group on that project, but not like it's just like in a mentor capacity, not like working on anything right now. I guess right now the work aspect is a bit busy at this time
Mm.
of the year. It's before the November, like when everything slows down. We have a lot of work in September, October months. So yeah,
And then in December it's chill.
yes, a bit chill during the holidays. Yeah.
Okay.
I guess it's the
Yeah.
same for most companies. I think I had similar experiences in
Yeah,
Morgan Stanley or Tesla.
In Europe definitely.
Yeah, yeah.
I don't know about the States, but
Yeah, I think side projects are when like I sometimes start something in December and then it's good if I'm able to complete it. Otherwise, I wait for the next December to take it off.
mm,
But
yeah.
yes, yeah, I think mentoring is easier because you have people actually working on something and who have more time to work on it, and you can help them in their process.
Mm, yeah.
So yeah.
What I like about mentoring is you can test ideas without actually spending a lot of time implementing them. But you know
Yeah.
the outcome, you learn the outcome from the person you mentor. So you can just say, hey, you can try this and that. And then a few days later, they come and say if it worked or not, right? And then you still learn from this experience too. Like you not only teach, you also learn.
Mhm.
And then you can know, okay, this thing for this case, maybe not is the best one. So we can try something else. So then you also um, get experience by mentoring.
For sure. I think that's how it's been working. And even like if you have like a bigger team, you can try out multiple ideas at a time. And
Yeah, yeah.
the people actually working on it, they join that project because they like it and they're like super invested in it. So it's nice to work along. They're super passionate about it.
Mhm,
So it's you trying out different ideas without actually, spending a lot of time, but you also get to mentor people. So yeah, it's
mhm.
it's a mix of good things. Yeah.
With all these new things coming out of AI, LLM, and whatnot, so since you were working computer vision, but all these new things, they are mostly related to NLP and texts. Um, do you also find time to try to stay up to date with this field, or you're focusing more on what you do at work?
Actually, I in CMU I was in the Language Technologies Institute, so I actually studied NLP and then transitioned to CV just before the whole ChatGPT boom.
Interesting.
Yeah, I graduated in December 2022, and then like I guess ChatGPT was around the same time, and like few months later it was like super big, and then the whole AI bubble with the
Mm-hmm.
LLMs like booming off. But yes, I do definitely stay abreast with everything. Like even when I was switching my roles, like from Tesla to Waymo, I did a lot of different interviews, and the way it works in the industry is like although you are from a CV background, it's the same underlying fundamentals. So, you still are eligible to interview for many of the LLM roles. And I did interview with like a bunch of places where it was only NLP focused, not much CV. But many times it's also a hybrid, like multimodal large language models are very popular now. And many teams who I guess like they need CV expertise along with their LL in-house like NLP folks. So definitely like I read a lot of papers that deal with this kind of multimodal LLM stuff. Read a lot of blogs or even like the LLM techniques that they use. It's good to have that knowledge because many of these techniques are general deep learning techniques rather than just that are applicable to LLMs. So you can use some of these techniques even for your models that work with CV data.
Yeah.
So yeah, at the end of the day, it's all deep learning, and
Mm-hmm.
it is as much interesting to know about it, and like it's as much
Mm-hmm.
useful.
Mm-hmm. So my master's was in 2013, 14. It wasn't focusing on even not on machine learning, but I was taking a lot of extra courses. In particular, I was quite interested in NLP, but NLP was quite different. It was pre-transformers era.
Yes,
So we were doing like logistic regression, this kind of stuff, right? To I don't know,
bag
and
of
identify.
words.
Yeah, so like if you want to identify part of speech, and
Hmm.
then there was I don't even remember how these models were called, but today you just throw everything at LLM and it tells you, okay, here's a noun
Yes.
or there's names, there are name entities. Back then, like you had to train models for that, and then you had to have a corpus, and then this it had to be labeled, and then you say for this corpus, like these are my named entities, like, and then you train a model. So these things are way easier today.
Hmm.
I wonder, in your case, when you studied NLP, you already covered deep learning, right? So for you, when these LLMs came up, like when they started to be big and ChatGPT, like people started using it, for you, because you studied deep learning techniques, right? So for you, it wasn't such a big leap, right?
Yeah, I think I still remember like when I was in undergrad, I did take a few ML courses, and that time it was these very basic natural language processing techniques like part of speech and entity correlation and bag of words and logistic regression. Like started off with that, but then like during that time, deep learning was also very popular. So in my master's, there was a lot of focus on deep learning, transformer-based systems because that was already big at that point. But now, like if you think about it, it's all based on the same fundamentals. Like
Mm-hmm.
your LLMs, they're based on transformers, which is based on like the attention mechanism, and that boils down to your representation learning, where you have like embeddings, and the embeddings have similarity, and the whole core of LLMs could be like said it's like a representation learning kind of thing,
Mm-hmm.
which uh, which is like where the basics began, which is where the fundamentals began. So for sure, like I did do a lot of deep learning, and that was really helpful when jumping to LLMs. But I feel like uh, with LLMs, there's a lot of more creative or ingenuity in how the pre-training, how they made it work, or the RL stuff. Like I have never taken an RL reinforcement learning course. I don't know what it is, but I did read the papers, and I it was hard to understand in the beginning, but like if you tie it down to okay some basic principles, and there's like so many good blogs explaining things about it. It does take some effort, but like you can just like try to piece together things. But it does take some effort. Of course, like if I had not learned about deep learning, if I had not learned about this representation learning or embeddings, it would have been much more harder for me.
Mm-hmm.
Yeah,
Yeah, I can imagine.
yeah. I remember, like I mentioned in Morgan Stanley, we were doing these basic things with the recommendation systems and like graph neural networks. It took me like almost 2 weeks to go through one paper, and it was
Mm-hmm.
just like 8 pages. And at that time, I did not have any background about deep learning. So I think
Mm-hmm.
having that background definitely makes it much easier to grasp these
Mm-hmm.
concepts.
Mm-hmm. So now when you read papers for you, it doesn't take 2 weeks usually.
No, no, it's like probably an hour at max.
Yeah.
So it's much
For
more
me, I think
efficient
it would
now.
be for me, I think it would be like 2 weeks if I needed to get into any modern papers like this. I don't know if I go to archive and take any paper about NLP or computer vision. Yeah. Well, good that we have ChatGPT, so I can ask it to explain things.
That is
That
so
helps.
good now. Like it was not there back when we were in school
Yeah,
and college
exactly.
doing assignments. Where was ChatGPT then?
Interesting that you mentioned you didn't have any prior experience with reinforcement learning, because I thought reinforcement learning is something that used quite often for um, driving too. Because for me, before this whole LLM space appeared, so for me, AI was there was machine learning, which was kind of part of AI, but for me, machine learning was machine learning, never like
Mhm.
AI. But
Yeah.
this reinforcement learning, you can actually get an agent to do things in the environment. And there were companies I interviewed with one of them who were creating these environments for self-driving cars to be like a test bed or whatever, like for testing.
Mhm.
So they have the environment with streets and whatnot, so they look very realistic. And I don't know. it was in Germany, so I guess like BMWs and Audis and whatnot, like companies who also work at on self-driving here in Germany, they could use this environment to test their cars, right? And the idea there was that they have this reinforcement learning framework where the car can just go wild and learn from like, okay, like if I hit a pedestrian, then there is a huge penalty, and then it learns not to do this, right? So for me, it was interesting. It didn't work out, so I didn't join the company. And it was funny. It was like a company with 4 people in a basement and a lot of GPUs.
Oh,
So
wow.
they needed a
Okay.
fifth one, and I thought, yeah, I have a kid and doesn't sound very stable.
Wow.
But
Okay. Okay.
yeah, but it was interesting.
Yeah. Yeah, reinforcement learning is kind of interesting. I think my first interaction with reinforcement learning was like with all these robots. Like we had these robo wars in college where you build your robot and like you go to a tech festival and you like compete
Right,
against each
right.
other. And I think reinforcement learning is still a big part of robotics. Um, for me personally, like so far in my career, I've like whatever career has been in computer vision or robotics, so to speak, it has mostly been on the computer vision side, so perception side, trying to understand the world. And then I believe like reinforcement learning comes into picture when you're trying to modify the behavior of the agent or trying to teach it how to like behave in the world it is in. So these are like two separate parts of the stack. Is one is you try to understand or make the agent understand the world, which is where I work, and then trying to make it behave a certain way, which is I believe like reinforcement learning could be used. So yeah, I never had to like even though I'm in the self-driving industry, I never had to like work on the other part of the stack. I don't think I'll be very good at it. I skipped all reinforcement learning courses in college because I just found it too hard.
Mhm.
So yeah.
Yeah, but I imagine also it's not, you will not let a car go wild and learn the way to interact with pedestrians right outside uh,
No, no.
to actually do reinforcement learning. Will be fun.
Yeah, that's for sure.
It's Carmageddon.
Honest, honestly, I don't know if we use reinforcement learning. I've never tried to find out.
It
Yeah.
looks like more like a fun project to do, like when you have a emulator, right?
Yes. Yeah.
Uh, but like in real life, probably you still have. There is actually a question from Oleg. Oleg is asking. I think the question is about self-driving. But the question is this full AI or mix of rules and AI? So I am assuming Oleg is referring to the self-driving. Because I guess like full AI would be this reinforcement learning, right? When the car just learns to drive by itself. But we still need to add some rules, right? Like what's the current state of the art in AI, in self-driving?
Yeah, I think like all environments, like even in reinforcement learning or other ways to teach the car, there would be some constraints that you impose upon it. Like, the rules of the world, like you shouldn't like go against the traffic. There are you need to put these constraints. Uh, so it's like I don't think it's full do whatever, learn however
Yeah.
you want to drive. Is definitely constrained by a lot of rules. And also, I would say, like, as you try to expand into different countries or different continents, there are a whole bunch of new rules that go about
Hmm.
over there. Uh, Sometimes you like even in the same country, even different cities have different patterns of driving. Sometimes the
Hmm.
drivers are very aggressive, sometimes it's like more rule following thing.
Right, right.
So it needs to be adaptable that way and
Hmm.
constrained in specifically.
Yeah. So in Italy and in Germany, it's so different, like the way people drive. So in Germany, at least in Berlin, people are driving slow and it's very easy to cross the street. But in Italy, especially in the south, good luck. Like you just have to go across the street, then they will stop. Otherwise, they will just keep driving, right?
Okay. Yeah. I think like it still needs to learn all these patterns
Yeah.
in the world. So a lot of
Mhm.
constraints over there. That's why it's such a hard problem.
Mhm.
It changes so much
Yeah.
with geographies.
Yeah. I was thinking about chess because in chess and then also in Go, they used eventually reinforcement learning to build these state-of-the-art models for playing these games. But what they did is they let the, I don't know how to say, agent or whatever, the players, the AI go wild and do whatever they want. So instead of learning from previous games, they just let the AI explore the game, and then eventually, because they were not bound by the training data, by the what people played in the past, they could play better than humans, right? But I guess with AI, with self-driving, it's kind of different, right? So you still need to obey. But yeah, in chess you have rules. The knight jumps like this, right? Or the bishop goes by on diagonals, right? So you have these rules in chess too.
Yeah, I think like the problem here, or the difference here, what I see is with chess, the rules are fixed. Like,
Yeah, very strict.
every piece has a given purpose and there's no rules beyond that. Like, you have these pieces and 16 pieces, and then you have these 16 set of rules. That's it. And then you can do whatever. And then you can explore, and then AI just has like full reign to do whatever it wants to do. But in self-driving, the rules are also constantly evolving. Like, you have like infinite number of rules, I would say. So it's hard to like teach the model in such a changing environment, so to speak. But yeah, I honestly don't know if we use reinforcement learning, but yeah, definitely the constraints do come into picture, whatever model we use.
Yeah, I see that there is a question from Adonis. He just asked it. How does the testing process go for sensitive cases like autonomous driving? Do developers inherit some general tests and they have to pass? Are there any stages? That's a very large, a big loaded question. But I guess, yeah, the question is like, how is testing organized for self-driving cars?
Yeah, I guess like it depends on like what change you're trying to do. So I work on pedestrians and gestures. So we have a bunch of like evaluations around cases where you have these pedestrians and or cases which have happened in the past, and you try to like rerun your new model on those cases. And then that is the first stage. And in the next stage, you evaluate overall with various different scenarios from the world where other pedestrians are involved. And like the question mentioned, there are different stages. Like, you start off small and then you slowly get like bigger and more comprehensive eval sets, and then you roll it out slowly. Like, you let drivers take it to the world and drive few miles around, then you deploy it to the larger fleet. So the rollout happens in stages that way.
Mhm. And another question about LLMs. We already talked. LLMs can do computer vision too, right? But they're kind of slow, right? Is there, do you think we can apply these LLMs for self-driving at some point? Like, does it actually make sense to use generative models for that?
Yeah, I think like there have been a lot of attempts. So if you see the latest state of the art, even in literature, or even some companies such as Wave, they are trying to in fact use like multimodal LLMs for a like end-to-end self-driving case. So there is definitely a lot of room, mainly because LLMs are trained or pre-trained on so much amount of data. They have so much of world knowledge that's easy to teach them more, or like have them behave certain ways because they already have a lot of knowledge. The challenge still remains in how do you make them fast enough. So you have to like probably do a lot of trade-offs. There needs to be a lot of different techniques, but definitely it's something that's been explored very actively in current research as well as by some companies. And there are in fact systems out there that use LLMs for the self-driving use case.
Because I guess we talked about different patterns in different countries, like Italy versus Germany. LLM might know about these things, right? It might know that uh, I don't know, if you go to south, it's more chaotic. If you go to north, it's more strict, right? So something like this. So maybe for it, it's easier to actually use it for, I don't know, I'm just making this up, I guess, but maybe it already knows because the way LLMs are trained, they're trained from internet forums where
Mhm.
Germans can go to forums and complain about drivers in Italy, right?
Yeah, I guess that's the hope that it has some semblance of knowledge about like a lot of different things that probably your well-curated data set might not have. Like when you try to train a model, you curate a data set and you only put in cases that you might be aware of. But with LLMs, the thing is that it has so much of world knowledge that there's a high possibility that it might know these things and it might help you in your tuning process to get it across the world.
Okay, maybe last question and we wrap it up. So if I want to work on self-driving cars, uh, what should I do? What should I study? Can I get into this industry?
Yeah, I guess like it again starts with deep learning. So the way I did it was I was good at deep learning. I got into the AI guide dog project, which was a similar use case. Like, you use vision and you use navigation. And that's how, like, that based on that one project, I got into Tesla. So I think it's a combination of knowing your fundamentals and doing relevant projects. So are if you do some computer vision related projects, it's a very good start. It's very good to have on your resume so that the company knows that, okay, you're familiar with the space. So they pick your resume and you at least get the chance to interview and then you like iterate and get better.
Mm-hmm. So a good pet project could be you write an app that you just show, like that uses your camera to describe things that you have. Like you just point at your room and it says, okay, there is a bed, there is like a
Mhm.
clock and things like that, right? I think I
Yeah,
saw
yeah, and I
demos
think
on
with
LinkedIn with YOLO.
yeah, like even with the LLMs, it's gotten so much easier that even if you like prompt an LLM with the appropriate prompt, you don't need to train anything. It will just tell you whatever it
Yeah,
is
yeah.
in the room.
Well, you also can ask ChatGPT to write you this app and then you learn how it did this, I guess.
Yeah, that's like two stages. You don't even write the app yourself.
Yeah.
Cursor or ChatGPT can do it,
But
and
it's so
then the
cool. Yeah. I asked recently a tool like Cursor, it's a coding agent. I asked it to implement a multi-agent system for evaluating projects that are on GitHub according to a set of criteria. And then half a hour later, I had a system that kind of works. I needed to tweak it a little bit, also with prompts, and then it was working. And then I could start studying how it was implemented, and I was like, okay, that's nice. Now I also know how
yeah,
to do this.
yeah, it's fascinating to me. Like, these kind of projects used to be projects and pet projects in college, and you used to spend like weeks on it, and now it's just done. But still, yeah, I tried using it once. It gets stuck in some weird bugs that you
Yeah, then
have
you
to
have to
solve yourself.
intervene and like
Yeah,
you have to also learn everything that the AI system came up with before you can
yeah,
fix the bug. So you have to know the entire code base.
yeah.
And
I
sometimes
think it's
it's
very good. Sorry,
difficult.
go ahead. Yeah, I think it's very good for setting a framework, like when you're starting a whole new project from scratch and you want
Yeah.
like a framework, it's really good with that. But if you want to get into the nitty-gritties, you have
Mm.
to know what you're doing. Yeah.
Okay. Okay. It was amazing talking to you. So thanks a lot. Good that we managed to work it out and find time that worked for us. Um, I'm sorry about you getting sick, so I hope you recover super quickly. So now I know it's very late for you, so you should go and rest, and I'll go have breakfast.
All right. Have a good day. Nice
Yeah.
meeting you.
So thank you, and thanks everyone for joining us today. And